Suppose we have our values for mean and median. What other applications or significance or importance of these values to other part in our statistics or data analysis? It's not that we have already our values for mean and median or mode, then we stop there. We stop using there. Okay, so the mean, median, and mode are very important in determining or testing our set of data or distribution. If this data is normal or not normal. So that if we found out that our data is normal, then we can analyze our hypothesis or we can test our hypothesis through parametric statistics. But if this data is not normal, meaning it does not conform with the standard of normal distribution, then we can make use of the non-parametric statistics. Okay, but when do we say that a given distribution is normal or not normal? Or when do we know that more of the scores or measurements are found below the mean or more of the scores are found above the mean? Okay, so the measures of skewness will help us understand and help us analyze or test whether our set of distribution is normal or not normal. If we talk about skewness, we are referring to the symmetric and asymmetry of a distribution. So in this case, we assume that a given distribution is normal so that half part of the distribution is 50% and the other part is also 50%. But if it is not normal, then one part is larger than the other part. Okay? So in a normal distribution, we regard that the mean, the median, and the mode are all equal. They have all equal values. So in that case, in this figure here, it is here where we can find our mean, median, and mode. The values of the mean, median, and mode are found here. The locations are found here. So in this distribution, the other part or half part of this is 50% and the other part of this is another 50%. Okay, so the mean, median, and mode divides the distribution into two equal parts if these are equal. In the half part of this distribution, there are three divisions. Same is true with other part. So to the right of our population mean, we have the first distribution, which is the population mean plus one standard deviation. The second division is the population mean plus twice the standard deviation. And the third is the population mean plus 3 of the standard deviation, thrice the standard deviation. To the left of our mean, or below the mean, we have the population mean minus one standard deviation. And the second division is the population mean minus twice the standard deviation. And the other one is the population mean minus thrice the standard deviation. So that from this point, from within one standard deviation from the mean, we have 68% of the scores are found within this area. Okay, whereas here in two standard deviation, we will find 95% of the data that are found within this part, and on the outer part we have 99.7%, which means that almost all scores are found within this area. There are two types of measures of skewness. So if the data is not normal, then we expect that it may either be negatively skewed or positively skewed. But how do we determine whether a given data or set of distribution or data is negatively skewed? What is our basis? We compare now the mean and the median. It is here where we can use our mean and median values. So negatively skewed if the mean and the median are not equal or the mean is less than the median. So that if the mean is less than the median, then there are more scores that are found above the mean. If this comprise of 100 scores, then, for example, we have 60% of the scores are found above the mean, and 40% of the scores are found below the mean. So that if it is negatively skewed, then more of the scores are found to the right of the mean or above the mean. On the other hand, a distribution is positively skewed if the mean is greater than the median. The mean is greater than the median. Okay? So more scores are found below the mean. More scores are found below the mean. Again, suppose this is 100 measurements or 100 data, then we can say that there are 60% of the data that are found below the mean, and 40% of the data or the scores are found above the mean. Suppose this refers to the performance of students, okay, in a major exam. So the negatively skewed indicates that most of the students' scores are found above the mean. So therefore, they are intelligent. Here, most of the scores are found below the mean. That means most of the students are not that very intelligent. Okay, you get the point? You get the difference? If it is mean greater than the median, more scores are found below the mean. If it is the mean less than the median, more scores are found above the mean. Okay? In order to determine the skewness coefficient, we can make use of this formula. 3 times the difference of the mean and the median all over standard deviation. So that if the mean and the median are equal, then our SK or coefficient of skewness is 0 because this is 0. Okay? This is 0. So the distribution is said to be normal. But if the value of skewness of SK or skewness value is less than 0, then the distribution is said to be skewed to the left. Whereas for SK greater than 0, the distribution is skewed to the right. Whereas in the kurtosis is different from the skewness. The kurtosis speaks about the peakness or flatness of a normal distribution. Okay? So here, if the distribution is peaker than the normal, we call that as leptokurtic. But if it is flatter than the normal, we call that as platykurtic. But if it is normal, then we call that as mesokurtic. And in finding the coefficient of kurtosis, we can make use of these formulas here. Okay? And in interpreting the result of kurtosis coefficient, we can make use of this method or description. So if the kurtosis value or coefficient is equal to 3, it is mesokurtic. If it is greater than 3, leptokurtic. And if it is less than 3, platykurtic. Examples will be provided using our Microsoft Excel. So please don't go away. This time we are going to use the Microsoft Excel in testing the normality of set of distribution by means of skewness coefficient. Skewness is just one of the ways or methods of testing the normality of a certain set of data. And the skewness, if the value of the skewness is 0, then the distribution is said to be normal. But if the value of skewness is less than 0, then the distribution is said to be skewed to the left or negatively skewed. But if the value of the skewness is greater than 0, it is skewed to the right or positively skewed. But before we go to the value of SK or skewness, may we first determine the values of the mean and median in each group of data here. There are 3 groups of data here, so we can make use of them in determining the value of the skewness coefficient, so we can tell whether this each set of data is normal or not, positively skewed or negatively skewed. So first, we have to get the mean. The mean is computed by getting the sum of all the numbers or data or scores divided by the number of scores. But in our Microsoft Excel, we just make use of the average, and then we drag it from G4 to G8, and then close parenthesis equals. So the mean of this data set is 25.4. Okay, the median, okay, the same procedure in our average. Okay, the median is 24. So in this case, the mean is greater than the median. The mean is greater than the median. So from these values alone, we can say that when the mean is greater than the median, this is positively skewed. Positively skewed. Which means if it is positively skewed, there are more scores below the mean. There are more scores below the mean. So if the mean is 25.4, then the scores that are found below the mean, which is 25.4, are 24, 23, and 21. So more scores are found below the mean here than the scores above the mean. There are only 2 scores that are found above the mean. These are only the 27 and 32. Now we prove that. We prove our findings through the skewness coefficient. So we have equals skew. We drag it from G4 to G8, close parenthesis, we have 1.01. So since the value of skewness is greater than 0, then it is positively skewed or skewed to the right. Again, more scores are found below the mean. More scores are found below the mean. Okay? So that's how we interpret and we take values of skewness and how we compare our mean and median values as to the normality of a certain set of data. Second example. The second example have scores of 80, 91, 94, 93, 78, 65, 55, 12, 100, and 88. So we will look into the values of our mean and median, and we prove that through our skewness coefficient again. So first, we have to get the average through our Microsoft Excel, so we don't need to solve it manually anymore. Equals, so we have 75.6, and the median value would be 84. Okay, so again, we compare mean and median. What can you say about the values of the mean and median? The mean is less than the median. The mean this time is less than the median value. So what does it mean? So if the mean is less than the median, then we have a negatively skewed distribution. Negatively skewed distribution. Okay, so again, if it is negatively skewed, the bulk is on the right. The bulk is on the right, which means that there are more scores that are found above the mean and small number of scores found below the mean. So if the average is 75.6, so we average first our values here. We go to sort. Okay, so from 75.6, meaning we have 1, 2, 3, 4, 5, 6. Okay, so our mean is 75.6 there. So there are 1, 2, 3, 4, 5, 6, 7. I should say we have 1, 2, 3, 4, 5, 6, 7. There are 7 scores that are found above the mean, and there are only 3 scores that are found below the mean. The bulk is on the right because the mean is greater than the median and it is negatively skewed. So more scores are found above the mean value. Okay, so let us prove this using our skewness coefficient. We have skew, equals negative 1.79411. So the skewness value or coefficient is less than 0. So therefore, it is skewed to the left and bulk is on the right. So more scores are found above the mean. Okay? And lastly, we have another set of data here. Okay, so these are not yet arranged from highest to lowest, largest to smallest. We have, okay, so we take the value of the mean. Okay, it is already arranged from highest to lowest. So we are going to compare first the mean and the median, but we have to get the values of these two locations. For the mean, we have average, $82. The average of this set of data is 82, and the median of this same set of data is also 82. So our mean and the median are the same. So that means that when we use our formula here, mean minus the median is 0. Therefore, our SK should be 0. So this must be normally distributed. So what about the value of the skewness? Let us verify. We have 0. It is equal to 0. 82. The average of this set of data is 82, and the median of this same set of data is also 82. So our mean and the median are the same. So that means that when we use our formula here, mean minus the median is 0. Therefore, our SK should be 0. So this must be normally distributed. Okay? So that means that 50% of the scores or data are found above the mean, and 50% of the data are also found below the mean. Okay? So what about the value of the skewness? Let us verify. We have 0. It is equal to 0. Since we have found out that this data is normal, okay, with skewness coefficient of 0, then we can determine the kurtosis coefficient. So we have equals Kurt from 84 down to 80 equals. So that's negative 0.91181. So if the value of kurtosis is greater than 3, that is leptokurtic. If it is equal to 3, that is mesokurtic. And if it is less than 3, that is platykurtic. So we have a platykurtic here. That means that the graph or the distribution is flatter than the normal.